ഹലോ വെൽക്കം ബാക്ക്. കഴിഞ്ഞൊരു വീഡിയോയിൽ നാം മാത്തമാറ്റിക്കൽ ലിമിറ്റ്സിനെ നമ്മുടെ ഡേ ടു ഡേ ലൈഫിലെ ഇവൻറ്റ്സുമായിട്ട് ബന്ധപ്പെടുത്തി ഡിസ്ക്രൈബ് ചെയ്യാൻ ശ്രമിച്ചു. നമ്മൾ ഈ വീഡിയോയിൽ എങ്ങനെയാണ് മാത്തമാറ്റിക്കൽ ലിമിറ്റ്സ് ഡിഫൈൻ ചെയ്തിരിക്കുന്നത്, മാത്തമാറ്റിക്കൽ ഡെഫിനിഷൻ ഓഫ് ലിമിറ്റ്സ് നമുക്ക് കാണാം. ലെഫ്റ്റ് ഹാൻഡ് സൈഡ് ലിമിറ്റും റൈറ്റ് ഹാൻഡ് സൈഡ് ലിമിറ്റും ലിമിറ്റ് കാൽക്കുലേഷനിൽ എന്തുമാത്രം ഇമ്പോർട്ടൻ്റ് ആണ്, അതുപോലെ തന്നെ ഈ രണ്ട് കാൽക്കുലേഷനിലും ഫംഗ്ഷൻ ഡെഫിനിഷന് എന്തുമാത്രം പ്രാധാന്യമുണ്ട്, ഇതൊക്കെ നമുക്ക് സ്വല്പം ഡീപ്പായിട്ട് കാണാൻ ശ്രമിക്കാം. നമ്മൾ ഇതുമായിട്ട് ബന്ധപ്പെട്ട് ഡിഫറെൻറ്റ് എക്സാമ്പിൾസിലൂടെ ഇത് കുറച്ചും കൂടി ഭംഗിയായി അണ്ടർസ്റ്റാൻഡ് ചെയ്യാൻ ശ്രമിക്കാം. ഇത് +1 മാത്തമാറ്റിക്സ് സിലബസിലെ ലിമിറ്റ്സ് ആൻഡ് ഡെറിവേറ്റീവ്സിൻ്റെയും അതുപോലെ തന്നെ +2 മാത്തമാറ്റിക്സിലെ കണ്ടിന്യൂറ്റി ആൻഡ് ഡിഫറൻഷ്യബിലിറ്റി എന്നീ ചാപ്റ്റേഴ്സിൻ്റെ ബേസിക്സ് ടോപ്പിക്സ് ആണ്. സോ ലെറ്റ്സ് ഡൈവ് ഇൻ ആൻഡ് മേക്ക് ദ ഡെഫിനിഷൻ ഓഫ് ലിമിറ്റ്സ് ഈസി ടു അണ്ടർസ്റ്റാൻഡ്. To start with, let us consider the function f of x is equal to x square. If you look at the graph of this function, x ന്റെ value 0 വരുന്നതോറും y യുടെ value comes down and it approaches 0. At this point x equal to 0, the value of y is also 0. We can say that as x tends to 0, f of x tends to 0. Symbolically, we write as limit x tends to 0, f of x equal to 0. In general, if as x tends to a, f of x tends to L, or we write it as limit x tends to a, f of x equal to L. Here L is called the limit of the function as x tends to a. Now consider another function f of x equal to mod x. Here we can see that for the values of x near to 0, the function value f of x moves towards 0. So we write limit as x tends to 0, f of x is equal to 0. Now consider the function f of x equal to x square minus 4 divided by x minus 2, where x not equal to 2. We can see that when x equal to 2, this function takes the form 4 minus 4 by 2 minus 2, which is 0 by 0, and that is indeterminate form. So the value of x equal to 2 is excluded from the domain of this function f of x. Now considering the values of x near to 2, we can see that the function value approaches 4. So we say that the limit of f of x as x tends to 2 is equal to 4. Next, consider the function defined as fx equal to 1 if x less than or equal to 0 and 2 if x greater than 0. Observe the definition and its graph. The function is split into two separate sections. For x less than or equal to 0, it is a horizontal straight line, y is equal to 1. And for x greater than 0, it is another straight line, y is equal to 2. Obviously, x equal to 0 is a special point, so that towards left of it, the function is y is equal to 1, and towards the right of it, it is y is equal to 2. So when x approaches 0 from the left of x equal to 0, the value of the function is 1. And when x approaches to 0 from the right of x equal to 0, the value of function is 2. This leads to two limits, namely the left hand limit and the right hand limit. We say that the left hand limit of f of x as x tends to 0 is 1. And the right hand limit of f of x as x tends to 0 is 2. Symbolically, we write limit x tends to 0 minus f of x is equal to 1, and the right hand limit as x tends to 0 plus f of x is equal to 2. The minus sign after 0 denotes the left hand limit meaning x takes values less than 0. Similarly, the plus sign denotes the right hand limit, meaning x takes values greater than 0. This behavior has an important impact on the limit of the function at x equal to 0. We say the limit of the function at x equal to 0 exists if and only if these two limits, namely the left hand and the right hand limits, are equal. So in the above example, as both the left and right hand limits are not equal, we say the limit of the function as x tends to 0 does not exist. It is important to note that the idea of limit of a function at x equal to a is quite different from the value of the function at x equal to a. Both may be same or different. In this example, the value of the function is same as its left hand limit and not the right hand limit. So what is a limit and what are the left and right hand limits? Looking at the values of f nearby points of x equal to a, are you able to predict or what value do you expect for f of x at a? There are two ways. Either you can observe the values of f of x to the left of a or the values of fx at the points to the right of a. In the first case, we say the left hand limit of f of x at x equal to a, and the second case we say the right hand limit of f of x at x equal to a. If both these expected values coincide, we call the common value as the limit of the function f of x at x equal to a, and we denote it as limit x tends to a f of x. If they do not coincide, we say the function does not have a limit at x equal to a. Finally, let's consider an analogy which may help understand the concept of limits. Let's imagine a boy climbing a hill. At the top of the hill, there is a small flag. Imagine a distant observer watching the boy as he climbs from the left side. By carefully observing his path, the observer feels sure that by the time it's 30 minutes, the boy will reach the flag. In this case, we can think of the flag as the left limit. It is the point the boy is getting closer and closer to as he climbs from the left. Next, imagine the boy climbing the same hill, but this time from the right side. Once again, the observer sees that the boy is steadily approaching the same flag, and at 30 minutes, it seems he should reach it. So here, the flag becomes the right limit, the point he is approaching from the right. Now, since both the left and right sides lead to the same flag at the 30-minute mark, we say the limit at 30 minutes is the flag. This is what a mathematical limit means. When we approach a point from both sides, if we get closer and closer to the same value, that value is the limit.